A very good evening to everyone logged in on today's session. On behalf of AIM and the ATL team, I welcome you all to the first session in the series of sessions we have planned for the ATL Space Challenge 2021. As you're aware, the ATL Space Challenge has been launched in collaboration with ISRO and CBSE, and these sessions will have scientists and expert speakers joining us and helping our young innovators in identifying the problems to devise solutions for the ongoing challenge. Kindly note, the challenge is open for all the students across the country, which means even if your school does not have an ATL, you can still participate in the challenge. Today's session is on the topic Introduction to Space, and we have Dr. Rajshri Buthale from ISRO joining us. We will understand the various themes under which you can submit your entries for the Space Challenge and how you can leverage the various technologies to come up with the most innovative solutions. Dr. Rajshri is presently the Group Director of the Training, Education and Outreach Group at NRSC Hyderabad, ISRO. She has worked at regional centers of NRSC at Jodhpur for 21 years and also at Nagpur. She has more than 30 years of experience of working in geospatial technologies, particularly in the field of water resources and cryosphere. As a member of the 35th Indian Scientific Expedition to Antarctica, she visited Antarctica to carry out research. She has received many awards for paper presentations, appreciations, and ISRO Team Excellence Award. She has featured as one of the 51 achievers of Women in STEM in the e-book published by Confederation of Indian Industry recently. Dr. Rajshri has authored a book titled Antariksha Ek Khoj, which was awarded the second prize in Delhi Book Fair 2020 under the reference book in Hindi category by the Federation of Indian Publishers. She has also written a book called Plate Art, which transforms food into visual art. On behalf of the AIM and the ATL team, I welcome you, ma'am, for today's session.
Thank you. Now, can I start now?
Yes, ma'am, please.
Okay. Just give me 1 minute to share my screen, and I will share my presentation. Can you see my presentation? Can you see my presentation?
Yes, ma'am. What is it?
Okay, I can start now. Good afternoon, everyone. All the students who have joined today to this ATL ISRO CBSE Challenge ISRO Challenge program. I will be telling you about Indian Space Program, its achievement, a little bit about me as per the instructions by Nava. I'll tell about me, how I achieved and what I feel should be the things which should be done by the girls and the boys and how they should take challenges. And in the end, I will show you some 2-3 videos. And with that, I will end my presentation and it will be open for question answer session. So when we talk about Indian Space Program, there are many who question the relevance of space technology in the developing nation. But we know that if we have to play a meaningful role nationally and in the Committee of Nations, we must be second to none in the application of advanced technology for the benefit of man and society. कई लोग होते हैं जो कहते हैं कि हमें जो है अंतरिक्ष की गतिविधियां हमें नहीं करनी चाहिए क्योंकि हम विकासशील देश हैं, लेकिन हम जानते हैं कि सुदूर संवेदन तकनीक को एक विशिष्ट स्थान प्राप्त है जिसके उपयोग से जन कल्याण की योजनाएं बनाई जाती है और जिसके द्वारा भारत की प्रगति में सहायता मिलती है. और ये किसने कहा? ये कहा था डॉक्टर विक्रम साराभाई, हु इज द फादर ऑफ इंडियन स्पेस प्रोग्राम, एंड इट वाज हिज विजन बेस्ड ऑन विच द एंटायर programs of ISRO are based. So let us see the accomplishments in space. We have up till now total 194 missions which have taken place. In that, 82 are launch vehicle missions, 112 are spacecraft missions. We launched 342 satellites of 33 countries. We started with satellite launch vehicle, came to augmented satellite launch vehicle, then polar satellite launch vehicle, geostationary satellite launch vehicle, and LVM-3. If we talk about PSLV, Polar Satellite Launch Vehicle, we have more than 50 successful flights of PSLV. And then we have now GSLV Mark III, and GSLV Mark III extended version for taking heavy satellites into the space. And all these things are used for space technology applications. And you all must be knowing about Gaganyaan, where we are planning to send human in space. So we have space capsule recovery experiment, reusable launch vehicle technology demonstrator, crew model, and scramjet engine technology demonstration. So these are our total accomplishment into the space up till now, with 100 presence of methane, and then other sensors were also there to explore Mars surface. Next one is the Chandrayaan-2. You all know about Chandrayaan-2 again. It was launched using GSLV Mark III. It is a more than GSLV Mark III is a three-stage vehicle which can launch 4-ton satellites into the GTO orbit. I already told you about GTO orbit. And then it had orbiter, which is still orbiting around moon with 8 payloads, and it is orbiting at an altitude of 100 kilometer by 100 kilometer. And then lander Vikram and rover Pragyan, you know that unfortunately lander Vikram could not land in a safe way. But if you talk about orbiter, it has got terrain mapping camera, and then it takes pictures in the 4 view, nadir view and aft view. कोई भी इमेज का 3 डायमेंशनल पिक्चर प्राप्त करने के लिए ये जरूरी है कि इमेज को 2 डिफरेंट स्थानों से देखा जाए. सो इसमें हम 4 व्यू, नादिर व्यू एंड आफ्ट व्यू से सेम प्लेस को देखते हैं, और जिसके द्वारा डिजिटल एलिवेशन मॉडल इज जनरेटेड. तो यहाँ पर आप देख रहे हैं कि चंद्रयान पिक्चर के द्वारा एक क्रेटर का, लिंडरबर्ग क्रेटर का 3 डायमेंशनल पिक्चर आपको दिख रहा है. और लेफ्ट का जो पिक्चर है, इसमें बहुत सारे जो है आपको वहां के जितने भी मून के जो क्रेटर्स हैं वो सब आपको दिख रहे हैं. और इनके द्वारा हम क्या क्या पता लगा सकते हैं? लावा ट्यूब्स, राइल्स, ल्यूनर डोम्स, ताकि भविष्य में यदि हमको वहां पर जाके कॉलोनी यदि बनानी हो तो वो लावा चैनल्स और दूसरी चीजें जो है वो हमें उपयोग में आ सके. अब चूंकि मुझे कहा गया है कि मेरी जर्नी के बारे में थोड़ा बहुत मैंने आपको इसरो के बारे में बता दिया. मैंने इसरो ज्वाइन किया था 1987 में, और 1987 में ज्वाइन करने के बाद कई तरीके से कई तरीके के कार्य करने पड़े. आई हैव टू गो टू द फील्ड, बिकॉज दैट इज पार्ट एंड पार्सल ऑफ रिमोट सेंसिंग टेक्नोलॉजी, दैट यू हैव टू गो टू द फील्ड टू कलेक्ट सर्टेन ग्राउंड ट्रूथ इंफॉर्मेशन. Then I always feel that in one person's journey, one should never stop learning. Learning is a continuous process. And I also joined ISRO with my master's MTech from IIT Roorkee. And after that, after many years, in 2016, I completed my PhD. So learning is a continuous process, and whenever you get an opportunity to learn, you should always keep on learning. It is always helpful in the life. Then not only that, I also completed MBA, because as you grow in the organization, you should have the managerial skill and management skill. So for that, I also completed MBA. I got an opportunity. The picture which is showing here is from Antarctica. You can see the 3 antennas, the dome antennas can be, radome antennas can be seen, and this is the Bharati station. India has got 2 stations in Antarctica. One is Maitri and other is Bharati, and where the research, year-long research is carried out. And I got an opportunity to go to Antarctica. It is always good to take challenges whenever you are, and whenever the opportunity comes and any challenge comes, we should never be afraid of taking any challenges in life. This was before going to Antarctica. I was asked to do certain physical exercise, working on ice, walking for kilometers with the bags, with the duffel bag on your shoulder, pitching the tents, and also climbing the rocks and getting down from the rocks. So these were the physical exercises which we were supposed to do, and it was a challenge for me because I was 50 plus of age and quite heavy also. Then if you see but I overcome all the challenges. I completed the desired task, and then I reached Antarctica. And some of the pictures of the Antarctica you can see on the left side. And that is one of the wow moment, or one of the great moment of my life was there when I reached to Antarctica. And there, the people who were staying there, they welcomed me with the tricolor, with the vehicle and the tricolor, which was just moving in the air. That is one of the greatest moment of my life. This is where I am on the ice and on the sea ice. And here, you, as I mentioned, the center picture is Antarctica Bharti Station. And the challenges were there. I enjoyed the challenges. Weather was very harsh. You can see that here in this picture, the bottom center picture, you can see that everything is covered with snow, and you have to work in that. Whenever I got the opportunity, I always did lot of cooking. So whatever you do, whatever the time comes, you should overcome that. Whenever we were not going out for doing work, we were busy in kitchen. So I did lot of cooking, and I enjoyed thoroughly, and my other teammates also enjoyed. There were challenges. My journey had challenges, particularly in Antarctica. You have to dig a big trench to take the observations. You have to carry the instruments. You can see here, the center picture shows the instruments. Then you have to wear a lot of winter clothing to do the experiments, because the moment you remove your gloves, the temperature is below 0 degrees centigrade, so you are not able to work, and the frostbite may come. So extreme windy, freezing conditions for taking reading and observation. The bottom picture, you can see that I am on a sledge, my instrument, and then I am on a ice surface over ocean. So this is a 2 meter of ice surface above ocean, and you are always tensed. If suppose ice breaks, you will go deep inside the ocean with no chance of survival. But we know that where we have to go with all. Then there are so many crevasses. Here you can see this picture, bottom center picture. You can see that crevasses. So you should identify inhospitable terrain is there. And then long outside working hours. And naturally, the basic issues will be there. You don't have any toilet facility or anything, and you are wearing the dangri suit. So these are all some of the challenges which we have to face, but we should take all the challenges whenever they come. So now another thing which was there was penguins. So I got an opportunity. It was again a wow moment for me when I got an opportunity to see the Edley penguins. And another challenge which I took was, I feel that nothing is impossible. As I mentioned you, when I went to Antarctica, I was quite heavyweight. I was more than 70 kg of weight. But I took a challenge there that no, I have to reduce the weight, and I reduced 10 kg weight after coming from Antarctica. I feel always one should be creative in the life. That really helps you in achieve your goal. Once you are creative, once you do something in the life, that gives you pleasure, that gives you happiness. So these are some of the examples of my creativity. As already mentioned, I wrote a book, Antariksha Khoj, which is published by scientific publishers. It is available online. Online, I mean to say, anyone can order the book. And this book got award also from ISRO, and also from publishers in the Delhi Book Fair. Then I have the creativity where I published another book, which is not a scientific, but it is a bilingual book published by Notion Press. It is a plate art. Why I am showing you that? This gives me pleasure. I use vegetables, I use fruits to create a art which is called plate art. And every day, depending upon what occasion is there, suppose a Navy Day is there, or no bribe day is there, or whatever day is there, water day is there, I create some plate art and I share with my friends. This gives me a lot of satisfaction to complete my official task with more vigor and more energy. And that is what I feel, that everyone should be creative in the life and should do something creative. Right side picture, what I have done is a life and journey of a woman. So right from a toddler, then she grows, and then she has become a girl child. So a woman, she has become a woman. So that is the journey I tried to depict using vegetables. Okay. So now coming back, that was my journey part, because other things have already been told, that I did BE or MTech and then PhD, and then how long I have been working. I had been to Mauritius, and I was there to for a few months to head the Mauritius Remote Sensing Center. So now coming back to Atal Space Challenge 2021, where we are celebrating the World Space Week 2021, where the theme this year is Women in Space, and Azadi Ka Amrit Mahotsav also is being celebrated from 15th August 2021 to 15th August 2022, and we will be having a lot of programs under this. So you all know that there are 4 topics which are given: explore space, reach space, inhibit space, and leverage space. I'll be talking a little bit about each, and then more on the leverage space, about the geospatial technology, drone technology, and how the data is visualized. So coming to exploring space, we can do some games, we can make apps, we can make some robotics. What information can be given on exploring space? We can give information about galaxies, Milky Way, nebulae, what is a light year, how the galaxies are classified. So you can make apps on that. You can make small games using this, where you can show certain galaxy, and you can ask people to identify what type of galaxy it is there based on certain the classification, which is standard classification. How the galaxies are made, the information can be given. Similarly, on stars, क्लासिफिकेशन ऑफ स्टार्स कैसे क्लासिफाई किए जाते हैं, उनके कलर्स के हिसाब से वो कैसे क्लासिफिकेशन होते हैं. ग्रुप ऑफ स्टार्स हम जानते हैं, जोडेक साइंस है, दे आर द ग्रुप ऑफ स्टार्स. You can have apps or games on exploring of space. Saptarshi, constellations, zodiac signs. Similarly, solar system, आप सभी को पता है, there are planets are there. Their details can be there in the games, and the planets are represented by certain symbols. So you can have some quiz-based games also. Exploring space, you can have the timeline and the history of how the first satellite was, Sputnik was sent into the space, or when the first man went or the first woman went, who did the first walking in space. Similarly, satellites also, we have the history. We started with Skylab, we have International Space Center station. So all these things can be done in the form of games, apps, or robotics, and you can do on explore space. Then leverage space. So, sorry, I think, yeah. Yeah, leverage space, that is the fourth topic. So that has got geospatial technology, drone technology, and visualize of the data. Now in geospatial technology, we talk about geographical information system, remote sensing. I'll tell about remote sensing, what it is, क्या होता है, geographical information system क्या होता है, global positioning system क्या होता है. फिर ड्रोन टेक्नोलॉजी में आप कैसे ड्रोन के डाटा को आप विजुलाइज करते हैं, and then you can identify different features on that, and how you visualize the satellite data for monitoring earth conditions, weather, climate, and how this is used in other different applications which you can utilize for making either apps or making other things. Okay, so let us again come back to the National Space System. We have launch vehicle at one end, INSAT series of satellite, that is the geostationary satellite, and Indian remote sensing satellite. Launch vehicle आप सभी को पता है. Launch vehicle जो है, जैसे मैंने बताया था, we started with satellite launch vehicle SLV-3, जो 40 kg का payload mass जो है वो space पे भेज सकता था. Then we came to augmented satellite launch vehicle, जहां पर 150 kg का पेलोड मास जो है वो भेजा गया. उसके बाद PSLV, पोलर सैटेलाइट लॉन्च व्हीकल एक्सेल वर्जन, जिससे हम 1.86 टन यानी अराउंड 2 टन kg के सैटेलाइट को पोलर सन सिंक्रोनस पोलर ऑर्बिट में, यानी विच इज 475 किलोमीटर एंड अबव, हम भेज सकते हैं. सिमिलरली GSLV Mark 2 and Mark 3. GSLV Mark 2 can send 2.2 ton satellite in GTO, and GSLV Mark III can send 4-ton satellites in GTO, and it has got solid, liquid, and cryogenic stage, and whereas PSLV has solid and liquid stage. So ये जो है ये हमारे geostationary सैटेलाइट्स हैं, जिसे हम कहते हैं कि भूस्थिरीय उपग्रह, यानी जैसे पृथ्वी वेस्ट से ईस्ट की ओर चक्कर लगाती है, उसी तरीके से इक्वेटोरियल प्लेन यानी भूमध्य रेखा में ये सैटेलाइट जो है वो पृथ्वी का चक्कर लगाते हैं। इसलिए ये हमेशा पृथ्वी के एक स्थान को ही देखते हैं। यदि इंडिया ने इसे लॉन्च किया हुआ है तो ये हमेशा इंडिया की तरफ जो है वो देखेंगे। तो ये हो गए जियो स्टेशनरी सैटेलाइट। दूसरे होते हैं सुदूर संवेदन यानी रिमोट सेंसिंग के उपग्रह, जो पोल से पोल पृथ्वी का चक्कर लगाते हैं और एक नियत समय के बाद आफ्टर ए फिक्स इंटरवल ऑफ टाइम कवर एंटायर अर्थ. Okay, so these are two types of satellite. You can make certain apps to display all this kind of information. Then we have the INSAT series of the satellite. We have INSAT family. We started with INSAT 1, INSAT 2, INSAT 3, INSAT 3B, Apple, and so many series of satellites are there which have been launched over a period of the time in the geostationary orbit. And what for these things are used? You remember, first one, what was told, that the satellites or the technology is used for socio-economic benefit of the nation. So TV broadcasting is done by INSAT series of satellites, mobile satellite services, radio networking, search and rescue services. India is a part of International COSPA Treaty, where anything which comes, ship or aircraft, which sends an SOS signal, that is recorded by satellite, and immediately search and rescue option is carried out. Data collection platform. We have in ocean different data collection platforms. So directly from the ocean, the data information is collected, and then it is sent to satellites, and then from there it is again transmitted back to Earth. So these are the data collection platform used for meteorology, and every half an hour meteorological data is taken. So here you can see that I am showing you INSAT 3D cloud fraction for one day, right from the morning till evening, that how this the position of the cloud varies. So this is a way to display the climate related data also, either over ocean or over earth or whatever it is. Different parameters can be, which we get from INSAT series of satellite, can be easily displayed and presented. Okay, so when we talk about Indian remote sensing satellite, we have the we started with 1 kilometer resolution. I'll be talking about that, what is the resolution, and now we have a 1 meter resolution. From global coverage, we have come to application specific coverage. So we started with first satellite Aryabhatta, then Bhaskar, Rohini, then we have the IRS series of the satellite which were launched using our PSLVs, PSLV Polar Satellite Launch Vehicle. So we have IRS-1B, P2, P3, P4. These were launched using our Polar Satellite Launch Vehicle. Then, as I mentioned, our imaging capability from 1 kilometer, you can see here, I have shown you in circle, right from 1 kilometer, 360 meter, 188, 72, 56, 36, 23, 5.8, 2.3, less than 1 meter, and even 0.65 meter is there. So from 1 kilometer, we have come to 0.65 meter spatial resolution, 24 days to everyday repeativity we are talking about, and we can generate a map from 1 million scale to cadastral level scale. Now coming to what actually is remote sensing, I will tell in nutshell about remote sensing. रिमोट सेंसिंग यानी सुदूर संवेदन, दूर से किया जाने वाला संवेदन, उसे हम कहते हैं रिमोट सेंसिंग. इट इज द साइंस एंड आर्ट ऑफ कलेक्टिंग इंफॉर्मेशन अबाउट एनी ऑब्जेक्ट, अबाउट एनी एरिया और अबाउट एनी फिनोमिना विदाउट बीइंग इन फिजिकल कॉन्टेक्ट विद द ऑब्जेक्ट. आप भी रिमोट सेंसिंग कर रहे हैं, मैं यहाँ पर बैठी हूँ, आप वहां पर बैठे हैं. ह्यूमन बॉडी में 5 तरीके के सेंसर्स होते हैं, आईज, नोज, ईयर्स. सो इन सभी के द्वारा जो है हम दूर से ही पता लगा सकते हैं कि क्या चीज हो रही है। यदि कहीं पर आग लगी हो या फायर है तो वी नीड नॉट गो एंड टच द फायर, बट फ्रॉम a distance, because the temperature will increase, smoke will come. So from that we can identify what is about the area, about the phenomena. Similarly, area. So how the remote sensing data acquisition comprises of? We require a source of energy. Sun is the source of energy. Energy from the sun passes through the atmosphere, and then in the atmosphere some energy is absorbed, some energy is scattered, and some energy is transmitted. The transmitted energy is again interacts with the earth surface feature. So once the energy interacts, I'll be talking about that, and then energy is reflected. That reflected energy again through the atmosphere goes to the sensors which are on board satellite या spacecraft में जो सेंसर लगे रहते हैं या संवेदक लगे रहते हैं, उनके द्वारा वो एनर्जी रिकॉर्ड की जाती है और फिर उसे पृथ्वी पर ट्रांसमिट कर दिया जाता है और डिफरेंट डाटा प्रोडक्ट्स आर जनरेटेड। और हमारे दो तरीके की रिमोट सेंसिंग होती है, एक एक्टिव रिमोट सेंसिंग और पैसिव रिमोट सेंसिंग। जब हम सन की एनर्जी का प्रयोग करते हैं उसे पैसिव रिमोट सेंसिंग कहते हैं, और यदि हमारे सैटेलाइट से एनर्जी जो है हम पृथ्वी के ऊपर फेंकते हैं और वापस उसको रिकॉर्ड करते हैं तो उसे एक्टिव रिमोट सेंसिंग कहते हैं। तो ऊर्जा सोर्स की हम बात करें, एनर्जी सोर्स आप सभी ने पढ़ा है, सन इमिट्स इलेक्ट्रोमैग्नेटिक रेडिएशन जिसे हम विद्युत चुंबकीय तरंग कहते हैं। ये विद्युत चुंबकीय तरंगे, इसमें इलेक्ट्रिक वेक्टर होता है, एक मैग्नेटिक वेक्टर होता है, ये दोनों राइट एंगल होते हैं एक दूसरे से, एंड ऑल्सो दे आर राइट एंगल टू द प्रोपेगेशन ऑफ लाइट, एंड वी ऑल नो दैट द वेलोसिटी ऑफ लाइट इज 3 × 10⁸ मीटर पर सेकेंड। Okay, and then as I told you that when this energy strikes the surface of the earth, and we know that, we all know very well that energy neither can be created nor can be destroyed. It can be converted from one form to another. So we have the energy, incident energy is equal to reflected energy plus absorbed energy plus transmitted, परावर्तित, अपवर्तित और शोषित ऊर्जा का यदि हम को जोड़ेंगे तो वह आती हुई ऊर्जा यानी इंसिडेंट एनर्जी के बराबर होती है। और उस ये जो ऊर्जा होती है विभिन्न वेवलेंथ बैंड्स में आती है। हम सभी जानते हैं विजिबल बैंड के बारे में, अल्ट्रावायलेट, नियर इंफ्रारेड, तो वी हैव वन एट कॉस्मिक रेज, गामा रेज, एक्स रेज, देन वी हैव अल्ट्रावायलेट, विजिबल, नियर इंफ्रारेड, थर्मल, माइक्रोवेव, टीवी एंड रेडियो लॉन्ग वेव। सो ये पूरा विद्युत चुंबकीय वर्णक्रम या स्पेक्ट्रम होता है, और हम इसमें विजिबल बैंड, नियर इंफ्रारेड, थर्मल और माइक्रोवेव में हम सुदूर संवेदन जो है वो करते हैं। तो अब इसमें एक चीज जानना आपको जरूरी होती है कि जब पृथ्वी से क्रिया होती है तो यह क्रिया वेवलेंथ बैंड और उस पदार्थ के गुण धर्म के ऊपर डिपेंड करती है, यानी कैरेक्टरिस्टिक्स ऑफ दैट पर्टिकुलर ऑब्जेक्ट। नाउ टेक द केस ऑफ वाटर बॉडी, whatever energy is falling on water body, it gets absorbed, and so reflectance is very less. That's why in this curve the blue color y-axis shows the reflectance is very less. When we talk about vegetation, the green curve, vegetation reflectance is very less in visible part of the spectrum, because you all know that the plant absorbs electromagnetic radiation in the process of photosynthesis. तो चूंकि absorption ज्यादा होता है इसलिए reflectance कम होता है। तो ये सब चीजों का अध्ययन करके आप सुदूर संवेदन के द्वारा सैटेलाइट इमेज के बारे में पता लगा सकते हैं कि सैटेलाइट इमेज में क्या है। हमारे सैटेलाइट इमेज में 4 तरीके के रिजोल्यूशन होते हैं, स्पेशल रिजोल्यूशन, स्पेक्ट्रल रिजोल्यूशन, रेडियोमेट्रिक रिजोल्यूशन एंड टेम्पोरल रिजोल्यूशन। स्पेशल रिजोल्यूशन यानी हम किस ऑब्जेक्ट को कैसे देखते हैं। यदि समझो बेसिकली यदि हम ये कहते हैं कि हमारे सैटेलाइट का रिजोल्यूशन 1 किलोमीटर बाय 1 किलोमीटर है, यानी 1 किलोमीटर बाय 1 किलोमीटर से जो रिफ्लेक्टेड एनर्जी है that will be recorded by one picture element on satellite image. So that is the spatial resolution. If I say that the resolution of my satellite is 1 meter by 1 meter, it means from 1 meter by 1 meter of the ground, the energy will be reflected and it will be recorded by one picture element or pixel. So naturally, if I have 1 kilometer area and 1 meter pixel, in one kilometer, I will get 1 pixel if the resolution is 1 kilometer, but 1000 meters or 1000 pixels if the resolution is 1 meter. So better the resolution goes towards 1, less than 1, we get better and better picture, which you can see here: 72 meter, 36 meter, 23, 5.8, 5.8 and 2.5, where individual building and whatever has been constructed, the bottom left picture can be shown, and different type of resolutions are there. So how the picture changes, how the things change. Now here you can see same area of Hyderabad city. The people who are from Hyderabad can identify this. So entire Hyderabad at 56 meters. Then the next picture is 23 meter. You can see more water bodies in detail. Then at 23 meter, 5.8 meter, where Hussain Sagar can be easily seen and all the roads and by roads on the top right picture. Then we come to 2.5 meter, where still you can see the things in detail, and 1 meter, where even each tree can be counted. Each tree can be counted. So that is the spatial resolution. Then we have spectral resolution. I talked about the wavelength band, how in the different wavelengths we acquire the data, that is the spectral resolution. And temporal resolution means after how many days we see this, the satellite, the earth at a particular location, same location, that is called temporal resolution, कालिक resolution. और last resolution है radiometric, यानी हम number of gray levels जिसमें हम डाटा को acquire करते हैं 2 bit, 4 bit, 6 bit और 8 bit, that is called the radiometric resolution. So मैं यहाँ पर आपको कुछ सैटेलाइट के पिक्चर दिखा रही हूँ. टॉप लेफ्ट का पिक्चर जो है वो मानसरोवर लेक का है. उसके बाद का जो पिक्चर है वो एग्रीकल्चर एरिया है, जो स्प्रिंकलर इरिगेशन का कमांड एरिया है. उसके बाद का जो पिक्चर है, थर्ड पिक्चर, वो ब्रह्मपुत्र रिवर है जिसमें पूरा सेडिमेंट आया हुआ है. और टॉप राइट का पिक्चर जो है वो हिमालयाज का पिक्चर है. बॉटम लेफ्ट पिक्चर इज बॉम्बे, साउथ बॉम्बे. एंड देन जो नेक्स्ट पिक्चर है वो अमेजॉन रिवर का माइक्रोवेव डाटा का पिक्चर है. और बॉटम राइट का जो पिक्चर है ये जेट्टी एरिया है ओशन का, कोस्ट का. नाउ हम ये सब इतना सारा जब डाटा हमें मिलता है, तो ये डाटा जो हमें मिलता है उसको हमें प्रेजेंट करना है और एनालाइज करना है और बताना है. सो उसके लिए हम जो तकनीक यूज करते हैं उसे हम जीआईएस कहते हैं, जियोग्राफिकल इंफॉर्मेशन सिस्टम. सो जियोग्राफिकल इंफॉर्मेशन सिस्टम में क्या होता है, एक हार्डवेयर लगता है, एक सॉफ्टवेयर लगता है, लोग लगते हैं जो इस डाटा का उपयोग करते हैं, और हमें प्रोसीजर लगते हैं और डाटा लगता है. इन सबको यदि हम जब कंबाइन करते हैं तो जियोग्राफिकल इंफॉर्मेशन सिस्टम बनता है. जियोग्राफिकल इंफॉर्मेशन सिस्टम के द्वारा हमें मल्टीपल थीम की जानकारी प्राप्त होती है. हम एक थीम की जानकारी, मल्टीपल थीम की जानकारी, सोशल इकोनॉमिक जानकारी एक पर्टिकुलर लोकेशन पे हम प्राप्त कर सकते हैं. इसी तरीके से जैसे आप यहाँ पर देखेंगे लैंड यूज मैप है, उसके ऊपर हमने ड्रेनेज मैप डाल दिया है, उसके ऊपर विलेज बाउंड्री डाल दी है और विलेज का नाम डाल दिया है. सो यह जीआईएस की तकनीक है जिसके द्वारा आप रिमोट सेंसिंग या कहीं से भी प्राप्त किए हुए डाटा या आंकड़ों को आप उसे प्रेजेंट कर सकते हैं. यू कैन डिस्प्ले, यू कैन डू द एनालिसिस ऑफ द डाटा. यू कैन ऑल्सो डू queries. So like you can select a class, you have one image, from that you can select particular type of say I want only cropland, I want only kharif crop, I want only rabi crop. So इस तरीके से आप जो है पूरा क्वेरी बिल्डअप आप कर सकते हैं जीआईएस के द्वारा. थोड़ा सा मैं आपको बता दूं नेशनल रिमोट सेंसिंग सेंटर के बारे में. नेशनल रिमोट सेंसिंग सेंटर जहां से मैं आती हूँ, यह एक इसरो का यूनिट है. इसके हैदराबाद में 4 ऑफिस है, एनआरएससी बालानगर में, शादनगर में, जीडी मेटला और बेगमपेट में. बालानगर में एप्लीकेशन का काम होता है, शादनगर में सैटेलाइट से जो डाटा आता है वहां पर 4 एंटीना है, उसको हम रिसीव करते हैं. और इसके अलावा अंटार्कटिका में भारतीय स्टेशन में भी हमारा एंटीना है, 2 एंटीना है जिसके द्वारा डाटा जो है वो रिसीव किया जाता है, सैटेलाइट का डाटा. और फिर जीडी मेटला कैंपस है जहां पर, जिसके बारे में मैं आपको बताऊंगी, और बेगमपेट कैंपस है जहां पर हमारे एयरक्राफ्ट जो है वो रखे जाते हैं. इसके अलावा हमारे 5 रीजनल सेंटर्स हैं, जोधपुर, दिल्ली, कोलकाता, नागपुर एंड बेंगलुरु में, जो रीजनल काम करते हैं. ये सारी जानकारी जो मैंने आपको बताई, इसमें से बहुत सारी जानकारी भुवन पोर्टल, भुवन एक पोर्टल है जो आप एक्सेस कर सकते हैं, bhuvan.nrc.gov.in पर. इस पोर्टल पर सारी जानकारी जो है वो उपलब्ध है. भुवन में क्या उपलब्ध है, भुवन इसरो का पोर्टल है. इसमें 81 मिलियन लोकेशंस एंड फोटोज हैं, कई सारे ऐप हैं, और इसमें सैटेलाइट डाटा जो है वो डाउनलोड होता है, इमेज देख सकते हैं, मैप देख सकते हैं. प्लीज डू विजिट भुवन. भुवन में कई सारी इंफॉर्मेशन है, आप इस इंफॉर्मेशन को लेके कुछ आप ऐप बना सकते हैं. लैंड यूज का डाटा है, अर्बन लैंड यूज है, वेस्ट लैंड है. सो कई सारी डाटा जो है वो भुवन के ऊपर अवेलेबल है. आपको शायद जानकारी होगी या नहीं होगी, हमारा एक स्कूल भुवन भी है जो ई लर्निंग पोर्टल है स्टूडेंट्स के लिए, और जिसमें मैप जो है सीबीएसई के बेस के 9th और 10th क्लास के जो मैप्स होते हैं एग्रीकल्चर, वाटर, सॉइल, मिनरल, एनसीईआरटी सिलेबस के बेस के ऊपर, इस मैप के ऊपर आप लेयर्स देख सकते हैं। क्योंकि कई बार क्या होता है, ज्योग्राफी स्टूडेंट्स को बड़ा बोर सा लगता है, तो ये एक इस तरीके से स्कूल भवन बनाया गया है जिसके ऊपर आप क्विज भी खेल सकते हैं, आप और लेवल 1 लेवल 2 की क्विज भी आप कर सकते हैं। तब आप भुवन के ऊपर 3 डायमेंशनल में भी, यानी सैटेलाइट डाटा के को डीएम के ऊपर ड्रेप करके भी आप उसको देख सकते हैं। और ये कुछ अलग अलग तरीके के सैटेलाइट के इमेजेस हैं जो यहाँ पर मैं आपको कुछ दिखा रही हूँ। आप सीजनल चेंजेस के बारे में भी आप मॉनिटरिंग कर सकते हैं, जैसे यहाँ पर मई का डाटा और उसके बाद अक्टूबर का डाटा, जो पूरे के पूरा एरिया में बर्फ जमा हो गई है। रिमोट सेंसिंग का कई क्षेत्रों में उपयोग होता है। देयर आर लॉट ऑफ एप्लीकेशंस ऑफ रिमोट सेंसिंग डाटा, लैंड रिसोर्सेस, रूरल डेवलपमेंट, फॉरेस्ट इकोलॉजी, वाटर रिसोर्सेस, जियो साइंसेस, अर्बन डिजास्टर, सो मेनी climate, any you name any field, you can find the use of remote sensing data. डिजास्टर में जैसे, क्योंकि आपको यदि उसमें आप देखेंगे तो उसमें ये कहा गया है कि डिजास्टर में फ्लड मैप बनाने में, डैमेज करने बनाने में, हजार्ड में, बैंक इरोजन की स्टडी, अर्थक्वेक्स का डैमेज असेसमेंट में, साइक्लोन का इनिंडेशन, सो इस तरीके से ड्रॉट, फॉरेस्ट फायर, लैंडस्लाइड, अर्थक्वेक, साइक्लोन एंड फ्लड्स में रिमोट सेंसिंग के डाटा और जीआईएस की तकनीक का बहुत ज्यादा यूज होता है, दैट इज लीवरेजिंग स्पेस। और इतने सारे नेचुरल डिजास्टर है इंडिया में, उन सब के बारे में आप जानकारी जो है वो प्राप्त कर सकते हैं। यहाँ पर मैं आपको एक प्री एंड पोस्ट इमेज आपको दिखा रही हूँ। लेफ्ट साइड का जो पिक्चर है ये केदारनाथ डिजास्टर की प्री एंड पोस्ट इमेजेस हैं, जिसमें कलर्ड पिक्चर जो है वो पोस्ट डिजास्टर है एंड ब्लैक एंड व्हाइट पिक्चर जो है वो प्री डिजास्टर है, कहाँ पर रोड जो है वो पूरे कट गए थे। इसी तरीके से राइट साइड का जो पिक्चर है वो माइक्रोवेव डाटा से बालासोर उड़ीसा में किस तरीके से जो एरिया फ्लडेड एरिया है वो आप पता लगा सकते हैं, लैंड साइड का पता लगा सकते हैं, कोई कितने में एरिया में फ्लड्स आए हैं, उन सब बारे में आप डिजास्टर में बहुत अच्छे तरीके से इस तकनीक का प्रयोग कर सकते हैं। अगला है जो ड्रोन यानी अनमैन्ड एरियल व्हीकल्स, उसमें कई सारे सेंसर लगे जा सकते हैं, मल्टीस्पेक्ट्रल सेंसर, थर्मल, हाइपरस्पेक्ट्रल, और उसके कई सारे उपयोग हैं जिसमें आप ड्रोन के डाटा का आप उपयोग कर सकते हैं। और यहाँ पर एक बेंगलुरु कर्नाटक का एक स्थान का आपको ट्रू कलर इमेज, फॉल्स कलर इमेज और डीएम का डाटा आपको यहाँ पर दिखाया गया है। फिर जो टेक्निक एक होती है ग्लोबल पोजिशनिंग सिस्टम, जो सैटेलाइट बेस्ड रेडियो नेविगेशन सिस्टम है, and it is a solution to man's longest and troublesome problem, where on earth am I? And it is based on the principle of triliteration in 3 dimension. The left side picture you can see that once the three triliteration is, then you can know the position. यदि हम बात करें तो IRNSS है, इंडियन रीजनल नेविगेशन सैटेलाइट सिस्टम, जिसे हम नाविक भी कहते हैं, नेविगेशन विद इंडियन कॉन्स्टलेशन, विच हैज गॉट 7 सैटेलाइट्स इन स्पेस। थोड़ा सा मैं आपको लास्ट में आपको एनआरएससी की जनसंपर्क सुविधा के बारे में बताऊंगी। इट इज अ सेंट्रलाइज्ड एनआरएससी आउटरीच फैसिलिटी फॉर academia, NGOs, public industries are there, where we do outreach, training, outsourcing and exhibition. So we share the knowledge, we train the manpower, we have the partnership with academia, and we do the industry collaboration. Students come to us for visiting. I will tell you how many, like if you see the number of students who have completed project with us, BTech, MTech, MCA and PhD students. So 792 students have completed project with us. We came into existence just 4 years back, so only 4 years are completed. And workshop we have organized. We helped in BITS Pilani, in nano satellite, student technical papers. Our students, they publish papers, 22 papers are published by them. Then we celebrate talent days, where the students, they present their work by papers, and they make posters also. And we do the general competition for schools and colleges, quiz, painting, essay. And nowadays we are working in the virtual mode, and any school, if they want to connect with us, they can connect with us. We will do the virtual program. outreach facility at GD Metla, where we have an exhibition bus where the students, they come, we show them the facility, I will show you the video also. And up till now 47,000 people have visited us. We celebrate World Space Week, Remote Sensing Fortnight, National Science Day, Vikram Sarabhai Centenary Program, where 2.78 lakh students were benefited. This is the number of project students, as I mentioned, who have done the work with us. And this is previous ex-chairman, Shri S. Kiran Kumar, giving certificate to our students. And this was the Vikram Sarabhai Centenary Program by us. And bottom picture is NIT Warangal, where 20,000 students visited our exhibition. So after this, I will just show you small videos of 104 satellite launch, fly through over Tirupati, and models of launch vehicle and satellites. So in nutshell, thank you very much. Before I show you, and always we have to fly high, always we have to have certain aim in the life, and then automatically you will achieve your objectives. You can always visit our website www.nrsc.gov.in, bhuvan.nrsc.gov.in, and for outreach activity you can write to us at outreach@nrsc.gov.in, and student@nrsc.gov.in, and training@nrsc.gov.in. Okay, so now what I will do, I will just share the videos. Just give me. Now I'm showing you 104 satellite launch video, how it was done. We'll have to wait for 1 minute. Yes. So this is the 104 satellite launch video, which was done using PSLV. You can see now. PSLV with on 15th February. You must have seen it many times, this kind of launch. If not, please, whenever next launch is there, you kindly visit Doordarshan, you will see. This is how the satellites, they one by one, the satellites will be separated, and this is from the camera, onboard camera, and you can see that heat shield of the satellite is put in the heat shield that got separated. Now the satellite is exposed to the space. Second stage is getting separated now. Separated. Third stage, now it's separating. Now this is the first satellite, Cartosat 2S. Now that is getting separated in the space. Two ISRO nano satellites, INS-1A and 1B. Nano satellites are separated, you can see here. And now all the 104 satellites, one by one, they will be separated. Remaining slide. See, you can see here, small satellites are getting separated. And that way, all the 104 satellites were launched in space. Placed in the orbit successfully. Now I will show you a virtual tour to our facility where you can see different satellites, GSLV launch vehicle, GSLV Mark III. This is GSLV Mark III heat shield. The satellite is put into the heat shield. Vikas engine, which is an indigenously developed engine by ISRO. Then thrust vector control to control the thrust. Cryo stage engine. Cryo engine. And then this is the crew module, how the crew will be inside this, will be sitting and they will land back on Earth. So this is the crew module. Aryabhatta satellite, the model of Aryabhatta satellite. Rohini satellite, InSat 3D satellite, OceanSat satellite, ResourceSat satellite. These are different satellites which have a specific purpose. Reset microwave satellite, it has got an antenna to send the signal and receive. IRNSS, I told, the Indian navigation system, 7 satellites are there in this. GSAT, geostationary satellite, which is there in the geostationary orbit, and this is the deep space antenna at Bailalu, 32 meters, which is used when we send the satellites into deep space. We have Chandrayaan, now Mangalyaan, model of Mangalyaan. And then we have AstroSat satellite, which is a satellite for astronomical observation. And this is the space suit Gaganyaan, which our astronaut will be visible. Now I'll be showing you a fly through the satellite data, a three-dimensional, the digital elevation model. Satellite data is draped over digital elevation model. And we are now flying over Tirumala and surrounding. Tirupati, Tirumala, you all know Devasthan. So now we will be flying over that. Wind turbines you have just seen. You have seen the reservoirs, the dam, the guest house, Saptagiri guest house, Sudarshan complex, Vakuntam Q complex, and all these, the people who have gone there, they can relate these things with the. So what we have done, we took a satellite image and we took the digital elevation model and we have draped over them, and then the fly through was made. So this was in nutshell about the Indian space program, what all we do. And I tried to tell you about remote sensing technology, GS technology, and also showed you the different models of satellite launch vehicle and the satellites. And also we saw the launch of 104 satellites in space. And also we saw the fly through over Tirupati. So this is all from my side. Naba, if any questions are there, now it is open to back to you. Hello.
Yes, ma'am. I don't see any questions in the chat, but I would just, before we wrap up the session, I would just request you if you have any suggestion or advice to our young innovators who are just starting on this journey of the Space Innovation Challenge. What type of solutions or what type of approach they should follow when they begin this journey?
See, if you talk about if they are interested in joining ISRO, so there are different opportunities. Some opportunities come for visiting ISRO. We have Yuvika program where 9th class students used to take part in that, and then they used to get an opportunity to visit different ISRO centers, and that used to be almost 1 month program. Then we have Dhruv program, which is again launched by ministry and this, but due to the pandemic, presently these programs are stopped. We also have certain competition. Last year we had ISRO cyberspace competition where the students they took part in different competition. Once they complete their 12th class, after that they can join IIST Trivandrum, Indian Institute of Space Science and Technology for their BTech program. And for that they have to give the competitive exams, and the details are given on IIST website. After that, if they want to come to ISRO, they can do graduation. After that, we have ISRO Centralized Recruitment Board, ICRB. So through ICRB, again, they can give examination and they can get selected and posted in different units of ISRO. Apart from that, apart from technical wing, we have the other wing also, that is administrative wing. And from time to time, different ISRO centers and ISRO headquarter website, the requirements or the job requirements, always it is posted on the different websites. The students can join. Always, as I mentioned, you have to be inquisitive. You should try to learn, try whenever there is an opportunity, try to gain the opportunity. Don't believe in hearsay in WhatsApp forwards and on. Don't believe. If certain topic has come, kindly Google it, kindly see it, that what is the truth behind that. If someday you come to know that a satellite is going to be launched, you get all the background information, so that when you are watching the live telecast, So you will really enjoy. Basically, that inquisitive mind should be there, and don't hesitate to ask questions to anyone, whether it is your teacher, whether it is your parents, whether it is any neighbor. Always keep on asking question, and you should have. And second thing is that you should keep on reading, because with reading your knowledge improves, and then you get better and better in a particular subject, and you start enjoying the subject. So that is what I feel the student should do. And take challenges. Never stop taking challenges, and never stop learning. Usually it is told when the students they go to IIT or some good institutes. So till 12th, the parents tell, "Are 12th, just study up to 12th. After that, because life is very cool." But it is never like that. Life is never cool. The knowledge is a continuous updation process, and you have to do
Definitely, definitely, ma'am. Thank you so much for such an inspiring and motivational session. I would urge all the students to note that you can submit either a physical prototype or a digital solution, and you have to submit a video of your working solution for the entry into the space challenge. So yes, get started with your space innovation journey and become the next best innovator in the space sector. Thank you all for joining us for today's session. We also have a series of sessions, these information sessions for you. So which the details will be posted on our social media channels. So just keep checking and everything. Thank you, ma'am.
Thank you. Thank you so much.